Okay. In continuous distributions, we have the most important one, that is normal distribution or Gaussian distribution, it is also called. A continuous random variable. A continuous random variable is said to have a continuous random variable capital X is said to have normal distribution. I'll just write shortcut n dot d. Normal distribution or Gaussian distribution with parameters. What are the parameters of normal distribution? Mu and sigma. Mu is the mean, sigma is the standard deviation. Sigma is standard deviation. If it's probability density function or distribution function, if it's a probability density function, probability is given by f of x. Why f? Because it's a continuous distribution, I'll be going with integrand. And usually when I am integrating, the functions are denoted by f. Sigma under root 2 pi e power minus 1 by 2 x, of course small x I'll take, x minus mu by sigma whole square. Okay. X ranges between minus infinity to plus infinity. Of course, mu also ranges between minus infinity to plus infinity. And sigma would be greater than 0. Obviously, the standard deviation of the given distribution would be greater than 0. Now, I'll be denoting normal distribution by, just see here, the parameters n, mu, comma, sigma, guys. Also, or variance, you can write sigma square as well. Also, this notation is also there, about which I will talk a little later. Okay. Yeah. How do I verify whether f of x is a probability density function or distribution or not? Verify f of x is a probability density function. Density function. How do I verify it? Okay, or probability PDF, probability distribution function. How do I verify it? I take from minus infinity to plus infinity f of x dx. I will take and then accordingly I'll verify. Okay, 1 by sigma under root 2 pi integral minus infinity to plus infinite e power minus 1 by 2 x minus mu by sigma whole square dx. I'll take in the integrand and verify. Now, there are certain things which are important in normal distribution, the mean and the variance of normal distribution. Let's see how to do those. Mean of normal distribution. Mean of normal distribution. Okay. What do I do for mean of normal distribution? I'll be considering expectation of x. This is nothing but integral minus infinite to plus infinite x into f of x dx. What is f of x in normal distribution? One by sigma under root 2 pi e power minus 1 by 2 x minus mu by sigma whole square dx. Okay. Yeah. What I will do is I will go with the substitution, not the substitution. The normal variate z, the standard normal variate, Z is given by x minus mu by sigma. Of course, small x, whatever. Small x is small z, right? Okay, so I'll be going with that substitution. What's the value of x from this is mu plus sigma z. Okay, what's the value of dx from it? Dx would be what? Mu derivative is 0. Sigma is there. Dz is what I'll have. Okay, accordingly, I'll go with this substitutions. Of course, for x is equal to minus infinite, z would be infinite. I mean, minus infinite only. X is equal to infinite, z would be infinite. So limits doesn't change. Minus infinite to plus infinite. In the place of x, I'll be having mu plus sigma z. Okay. Also, 1 by sigma under root 2 pi would be written outside. Okay. E power minus z squared by 2. Instead of dx, I'll be replacing what? Sigma dz. Sigma dz is what I'll be replacing. This sigma and this sigma gets cancelled off. Okay, I'll write the integral separately so that I understand certain things. What that is minus infinite to plus infinite. Mu e power minus z squared by 2 dz is one integrand. I mean one integral. Minus infinite to plus infinite. There's one more sigma which can be written out z e power minus z squared by 2 dz is what I have. Okay. Now clearly I can see whenever I have integral minus a to plus a f of x dx, if I know the characteristics of f of x, then I can write certain things. Twice integral 0 to a f of x dx I can write if f of x is an even function. Okay. Similarly, it's 0 if f of x is an odd function. Odd function. Okay. So using that, I can clearly say the second integrand, integral whatever is there, second integral would be odd function. Why? Because what's the definition for odd function? F of minus x should give me minus f of x. Then it would be odd. F of minus x should give, if it gives me f of x, then it is even function. You can ask me if either of the cases, if I don't get either of those cases, then what do I say? It's neither even nor odd. I cannot write anything like this. Okay. So this is an odd function. So the second integrand goes to 0. This would be an even function. Okay. Put minus z and see, I'll get back the same function again. Okay. So what will this value be is 1 by under root 2 pi integral minus infinite to plus infinite. No, not minus, 0 to, I'm sorry. 0 to, because it's an even function. And then here I'll be having 2. Okay. Mu e power minus z squared by 2 dz. And the second integrand value would be 0. Now, to evaluate this integral, again, I don't have any direct formula. So I'll be going with the substitution. Z square by 2 is equal to t. 2z by 2 dz is equal to dt is what I will have. Okay. Yeah. So do I have z dz? No. So I have only dz. So what's the value of dz? dt by z. What's the value of z from this? Z would be plus or minus under root of 2t. Okay. dt by under root of 2t. Okay. So that's what I'll be substituting here. 2 by root 2 pi. Limits doesn't change. For z is equal to 0, t is 0. For z is equal to infinite, t is equal to infinite. Okay. So integral 0 to infinite, mu also can be taken out. E power minus t is there. Okay. Yeah. dz would be what? dt by root 2 is there. Now root 2 I can write it outside. Okay. Root t is there in the denominator, right? I'll take it to the numerator. It would be like this. Now, this is nothing but a gamma function, guys. There's a definition for gamma function, that is integral 0 to infinite e power minus t power n minus 1 dt. Gamma of n is. So, this value turns out to be root pi. Okay, this value turns out to be root pi. Okay. Yeah, I'll explain the next video how it turns out to be root pi because it's becoming a lengthier video. This is the root 2, this is the root pi, and the value of that integrand turned out into root 2 is also there. Value of the integrand turned out to be root pi. So all these things get cancelled off, and finally I'll be left with mu. That would be the value of the mean of normal distribution. In the next video, I will show you how to find gamma function, what are the things about gamma function, and how to evaluate that integral.